Hello students, in this video I will explain with the other problems in the exercise 5.1. See this question, find the relationship between a and b so that the function f defined by f of x is equal to ax plus 1 if x less than or equal to 3 and bx plus 3 if x greater than 3 is continuous at x equal to 3. Here this is a slightly different question. Instead of verifying the continuity, here it is given that the function is continuous. You have to get the relationship between a and b. Now, given function is f of x equal to ax plus 1 if x less than or equal to 3, bx plus 3 if x greater than 3, and it is given that it is continuous at x equal to 3. And if the function is continuous, then you know that left hand limit and right hand limit and value of the function are same. Limit extending to 3 minus f of x is equal to limit extending to 3 plus f of x is equal to f of 3. And what is limit extending to 3 minus f of x? Just observe, 3 minus means less than 3. When it is less than 3, how the function is defined? Ax plus 1, and this will become like this. Limit extending to 3 minus ax plus 1 is equal to limit extending to 3 plus bx plus 3. So here f of x is equal to bx plus 3 when x is greater than 3 is equal to f of 3. What is f of 3? When it is 3, it is ax plus 1. That's why it is a into 3 plus 1, that is f of 3. You can simplify this further. A into 3 plus 1 is equal to b into 3 plus 3. And simplifying further, we will have 3a is equal to 3b plus 3 minus 1. Bring 1 to right hand side. And 3a is equal to 3b plus 2. Divide by 3, you will have a is equal to b plus 2 by 3. And this is the relationship between a and b. And see one more question. Show that the function defined by g of x is equal to x minus box x, that is greatest integer function, is discontinuous at all integral points. Here box x denotes the greatest integer less than or equal to x. Now it is given that g of x equal to x minus box x, and we have to verify the continuity at integral points. Let n be any integer, and g of n is equal to n minus box n, and for any integer, what is box n? N only, and it will become n minus n, which is equal to 0. And let us find the left hand limit and right hand limit as x tends to n. And limit extending to n plus f of x is equal to, here n plus means greater than n, okay, and g of x is x minus box x for all the cases, and that's equal to limit extending to n plus x minus box x. And this step is very important. As x tends to n, x will become n only. And what is box n as x tends to n from the right side of n? That means, for example, you take 2, and as x tends to 2, x equal to 2 only. 2 plus means it is greater than 2, 2.01, 2.001, like that. And what is box 2.01? It is 2. And box 2.001, that is also is equal to 2. And if x is approaching to 2 from the right side of 2, it is equal to 2. And as x approaches from the right side of n, it will become n. And next step, that's equal to n minus n, and which is equal to 0. Similarly, let us find the left hand limit, that is limit extending to n minus g of x, that's equal to limit extending to n minus x minus box x. And here also limit extending to n x equal to x only. But as x tends to n minus, what is box x? You just to observe. If n equal to 2, and 2 minus means slightly less than 2, for example 1.99. What is box 1.99? It's equal to 1. Even x is approaching n, you will get box x is n minus 1, and that's why this will become n minus 1. And what is n minus 1? Simplifying, you will have n minus n plus 1, which is equal to 1. and here left hand limit and right hand limits are not equal. That's why g of x is not continuous for all n belongs to z. Now you take this question, find all points of discontinuity of f where f of x equal to sin x by x if x is less than 0, x plus 1 if x greater than equal to 0, and which is similar to the previous question, but here function is trigonometric function, and f of x is defined for all real numbers, and let us take a real number c, and there we are the three cases, that is c is less than 0, c is greater than 0, and c is equal to 0. First let c is less than 0. When c is less than 0, what is f of c? F of c is equal to sin c by c. Here when x is less than 0, what is f of x? F of x equal to sin x by x, and f of c is equal to sin c by c. And limit extending to c, f of x is equal to limit extending to c sin x by x, and that's equal to sin c by c. Therefore limit extending to c, f of x equal to f of c, and therefore f of x is continuous at x equal to c. And let us take the second case, that is c is greater than 0. When c is greater than 0, and what is f of c? F of c is equal to c plus 1, because f of x is equal to x plus 1 when x is greater than equal to 0. And what is f of c? C plus 1. And limit extending to c, f of x is equal to limit extending to c x plus 1, because when c is greater than 0, it is x plus 1, and which is equal to c plus 1. And the limit extending to c, f of x is equal to f of c. Both of them are c plus 1 here. Limit extending to c, f of x equal to f of c. Therefore f of x is continuous at x equal to c. When c is greater than 0 or less than 0, function is continuous. Now let us check the continuity when c is equal to 0. Let c is equal to 0. What is f of c? That is f of 0. When it is 0, it is x plus 1, that is 0 plus 1. 0 plus 1 equal to 1. And limit extending to 0 minus f of x is equal to limit extending to 0 minus, what is f of x? Sin x by x, because when x is less than 0, it is sin x by x. And you know this standard limit extending to 0 sin x by x equal to 1. And similarly you find limit extending to 0 plus f of x. 0 plus means limit extending to 0 plus x plus 1, and which is also equal to 0 plus 1, and it's equal to 1. And here left hand limit, right hand limit, and value of the function are equal. Limit extending to 0 plus f of x, limit extending to 0 minus f of x, and f of 0 are equal. Therefore f of x is continuous at x equal to 0, and it is continuous everywhere, and the given function is a continuous function. Take this problem. Find all the points of discontinuity of f where f of x equal to x square into sin 1 by x if x is not equal to 0, and 0 if x equal to 0. It's a special problem, just to observe it correctly. Now the given function, let us write it, f of x equal to x square into sin 1 by x if x not equal to 0, 0 if x equal to 0. Let us take the first case, c not equal to 0. Here let us take c not equal to 0, because in both the cases function is defined in the same way. And when c is not equal to 0, what is f of c? F of c is equal to c square into sin 1 by c. Here when c is not equal to 0, sin 1 by c is defined, and x c square is also defined, the product is defined, and that itself is the limit of the function. And limit extending to c, f of x equal to limit extending to c x square into sin 1 by x, that's equal to c square into sin 1 by c. Here limit of the function is equal to value of the function. Therefore the function is continuous when c is not equal to 0. That is, at all the points c where c is not equal to 0, given function is continuous. And we have to check the continuity of the function at c is equal to 0. When c is equal to 0, you have to check whether this is continuous or not. And here we will use one important result to verify the continuity at c is equal to 0. And let c is equal to 0. And what is f of 0? F of 0 is equal to 0. It is given here. If c x equal to 0, what is f of x? 0. And to find the limit of the function as x tends to 0, x square sin 1 by x, we will use this sandwich theorem. That is, if you take three function, that is g of x, f of x and h of x. If g of x lies between f of x and h of x, if g of x lies between f of x and h of x, then the limit of the function also lies between this. Here for all x, f of x is less than or equal to g of x less than or equal to h of x. Then limit of the function, that is limit of g of x, also lies between limit of f of x and limit of h of x, which is called sandwich theorem. This result we will use, that is limit x tends to a f of x less than or equal to limit x tends to a g of x less than or equal to limit x tends to a h of x. And this is called sandwich theorem. And we have minus 1 less than or equal to sine 1 by x less than or equal to 1, because sine 1 by x always lies between minus 1 and plus 1. And if you multiply by x square, because x square is positive, we will have multiply by x square, we will have minus x square less than or equal to x square sine 1 by x less than or equal to x square. And remember, when the positive number is multiplied to any inequality, the inequality remains same. That's why we will have minus x square less than or equal to x square sine 1 by x less than or equal to x square. And now you take limit to these inequalities. Limit extending to 0 minus x square less than or equal to limit extends to 0 x square sine 1 by x less than or equal to limit extending to 0 x square. And you know this limit and this limit. And limit extends to 0 minus x square is equal to 0. And that is 0 less than or equal to limit extends to 0 x square sine 1 by x less than or equal to 0. And it lies between 0 and 0. Therefore, limit extends to 0 x square sine 1 by x is equal to 0. And hence, we will have the limit of the function and value of the function are equal, and limit extending to 0 f of x is equal to f of 0. Therefore, f of x is continuous at x equal to 0, and the given function is a continuous function. And with this much, I conclude this session, and let us continue other important questions in the next video. Thank you.